Okay, everybody, welcome to lesson 6.4 and 6.5 in your textbook, which covers similarity and corresponding sides. Let's go ahead and start off by talking about what similar figures are and what they have. And there's a little bit of a checklist here that you can follow in order to tell whether you're dealing with similar figures. For one, let me change the color of my ink here. First, they have the same shape, okay? One triangle doesn't necessarily mean it's similar to another triangle just because they're both triangles. They have to have the same shape, but the angles have to be they have to correspond. So if you look at these two shapes, which are terribly drawn triangles, it doesn't matter, but the angles don't really match up. And on this shape, the angles match up. This angle equals this angle equals that one. The ones that basically the corresponding angles are all exactly the same. And when I say, I should also preface this by saying, explaining to you what corresponding means. And corresponding basically means same relative position. So this angle right here is in the same relative position as this. This side right here, 4, is in the same position as this. One thing to be careful of when you're looking at corresponding sides and angles is that the shapes are drawn or oriented in a manner that is basically the same as the other. Because sometimes they'll be rotated or flipped around, turned around, or whatever, and you want to make sure that you're looking at them from the same perspective. Like I said, so 4 corresponds with 10, 12 corresponds with 30. Corresponding means same relative position. That's all that means. So what I'm doing here, the last thing I want to look at is whether the sides have equal ratios. So if I look at corresponding sides, like 8 corresponds with 20, 10 corresponds with 25. If I look at the ratios there, that definitely sets up a proportion. Those are equal. Those are absolutely equal to each other. 10 times 20 is 200. 8 times 25 is also 200. So you're dealing with a proportion here. And that will be true no matter how you look at it. 30 corresponds with 12, and 20 corresponds with 8. Now this doesn't come out to 200, but that doesn't matter. What matters is I'm dealing with equal ratios in this example right here. 8 times 30 is 240. 20 times 12 is 240. I know I got 200 over here, but that doesn't matter. What I'm looking at is whether this ratio equals this ratio, and it does. So we're looking at equal ratios, therefore these are definitely similar shapes. Okay, and here's another one if you just want to check and make sure, probably, if you want it just for good luck, make sure it works, and it does. And this also equals 240. Okay, now let's get into our first example. This example right here, we have similar triangles. Now, I'm just going to say that they're similar because of the example, but sometimes you have to figure out whether they're similar. But we're assuming for pretty much all my examples that they are similar. And we're looking for C. What is C? What is that unknown letter? So set up a proportion. I usually tell everyone just to, write some empty blanks here with an equal sign in there. Those are going to be your ratios eventually. Start with C. We're looking for C. C corresponds with 3. And on the big triangle, I'm going to use 12, and 12 corresponds with 4. And there you have it. Now to solve it by cross multiplying, 4 times C is 4C. 12 times 3 is 36. The next step after that is to solve it. Make sure you're not telling yourself, I'm done, I don't need to do anymore. You have one more step, which is to divide by 4. C equals 9. There you have it. On this example, we're looking for X. We have similar rectangles. And I don't know, I threw up that similarity symbol, and I didn't really talk about it, but that symbol right there, that's the symbol for similar. The symbol for congruent looks like this. And congruent means similar and equal. So that's why that looks like the way it does. But the similar symbol looks like that. You might see that from time to time. So we're going to set up our ratios to equal a proportion, and x, this is pretty simple. X corresponds with 8, and 26 corresponds with 16. Go ahead and cross multiply. 16x equals 208. Divide by 16, and you should get 13. All right, I know I went through that kind of quickly, but I'm assuming, I would say for the most part, I'm assuming you know how to solve it by now. You know the math behind solving a proportion. If you're not getting it, let me know in class, and we'll help you out. Okay, now here's one where you have a few things. You have m and you have x. We're looking for two things. We're looking for the variable m and the variable x. The unknowns, really. They're not variables because they're not going to be a bunch of numbers. They're only going to be one number. Doesn't matter what you solve for, but make sure you only solve for one letter. Don't try to solve for both letters at the same time. So I'm going to put m in there first. M corresponds with 7, and 4 corresponds with 14. Really, setting it up is kind of up to you, but whatever you do to set it up, make sure everything matches up. M matches up with 7. 14 and 4 match up with each other. It's got to be that way. If you don't set it up that way, you're kind of just guessing, or you're making it not work out right. So we're going to cross multiply. We get 14m. 4 times 7 is 28. Divide by 14, which you can probably do in your head, and you get 2. So there's our x. Our m. Our m equals 2. Now we're going to solve for our x value. Notice how I put the 2 in. Okay, now the x value, I'm going to put that in first, and then I'm going to make everything work around the x. Make everything kind of set up around that x. Now x corresponds with 8. 14 corresponds with 4. Cross multiply. 4 times x is 4x. 14 times 8 equals 112. Divide by 4, and you should get 28. And there it is. So now we've got our m, which was 2, and our x, which was 28. Okay, now let's go through one more problem here. This is going to be kind of a story problem where maybe drawing a picture of it helps, but these are classic ratio/proportion problems. You're going to see these quite often. They're sometimes done with a tree or with a ladder or a building or a person's shadow, and they're very typical in most math courses you're going to take. But here's the problem. All right, Daniel is 151 centimeters tall. He's casting a shadow that is about 60 4/10 centimeters long. He's standing near the Willis Tower. That's casting a shadow of 21,080 centimeters long. How tall, based on those shadows, based on those proportions there, or the ratios, I should say, based on all that information, how tall is the Willis Tower? So here's Daniel, looking very nice in his suit and tie. I took that picture today of him. And he's 151 and tall and 60.4 centimeters in terms of a shadow. That's really how tall Daniel is. I measured him today. No joke. There's Willis Tower. Okay, now this is not to not to scale, because it makes it, if that was to scale, Dan would be a giant. But just work with me on this. I couldn't fit. If I did put it on there, I'd have to make Daniel really small. You couldn't see him. But let's just pretend that everything works out. The height is unknown, but the shadow is known. The shadow is 21,080 centimeters long. So based on those proportions, you know, you know, the other thing too is to remember that, you know, the sun was probably coming down at a similar angle. You know, not I shouldn't say a similar angle, the same angle. You know, the sun is up in the sky, it's at a certain angle up there, and it's casting a shadow um, that is going to be in direct proportion to heights of anything, whether it's a tree, a building, a flagpole, but the heights will always be at the same proportion. Granted, you take the measurement at the same time of the day. If you're doing it at a different time of the day, yeah, then the sun's going to be either higher or lower in the sky depending on, you know, how long or how far after how you took that that measurement. So let me clean this up a little bit. So when we set this up, you know, you want to make sure the ratios match. So in my proportion, I'm going to put Dan's height, and I'm going to match that up with the building's height. Those corresponding. I know Daniel's not as tall as the Willis Tower, but that doesn't matter. You're looking at his height and the building's height. Those match up. They correspond. Then what we're going to do is we're going to look at the shadows. Dan's shadow compared to the building's shadow. And now it's just a matter of filling it all in. And I find, as you know, as teaching this as a math teacher and from a student's perspective, this is probably the toughest part, which is just setting it all up. Make sure everything matches. That's really important. Everything matches up. Height with height, shadows with shadows, flagpoles, heights with the tree's height. You know, whatever the problem's asking you to do, make sure everything matches up. Now I'm just going to fill in the blanks. Dan is 151 centimeters tall. Don't worry about putting in centimeters. Let's just worry about the numbers, and we can label it when we're done. The building's height is h. We don't know what that is. Dan's shadow is 60 and 4/10 centimeters. And the building shadow is a whopping 21,080 centimeters. And now it's just a matter of solving the proportion. If I cross multiply, 60.4 times h is 60.4 h. And then 21,080 times 151 is 3,183,080. So big numbers. And like I said in an earlier video, it's okay to use your calculators for this kind of stuff. So what do you do to solve this? Well, it looks like you have to divide both sides by 60.4. So do 3,183,080 divided by 60.4, and you get 52,700 centimeters. And that makes sense, because if we convert this to meters, which maybe that might make more sense to you, if we convert that to meters, we can move the decimal over 2, and we get 527 meters. And that makes sense to me, that a building like the Willis Tower would be 527 meters tall. And that does it. Make sure you guys fill in the rest of your note sheet and come in to class tomorrow with any questions if you were confused about anything. Okay, everyone, have a good night. See you tomorrow.